In this video, we're going to work example problems related to trigonometric functions of non-acute angles. Now, mainly we're only going to be looking at problems where either the angle or the reference angle is one of the special angles, so 30, 60, or 45 degrees. And you might be a little confused by this, wondering, well, why are we just doing these angles? In the next video, for the next section, I'm going to explain this more in detail, but if you think about it, up to this point, we haven't determined any trigonometric function values of specific angles that we know. We know what the angle is, other than the special angles. You might say, well, what do you mean? We've calculated all kinds of different trigonometric function values. Yes, we knew like the sides of the right triangle, the corresponding right triangles, for example. But we didn't actually know what the angle was. Okay, so if you're still a little confused by what I'm saying, just watch the video in the next section. I'm going to kind of review everything we've done so far and explain and give you the full context of what we've done so far and how we actually calculate trigonometric function values of like non-special angles, like 32 degrees or something if we don't know the side lengths of the triangle. So I'll explain all of this in detail in the next section. All right, the value of sine of 240 degrees is positive or negative because 240 degrees is in quadrant. What quadrant? So, okay, 240 degrees we know is between 180 and 270. So it's in the third quadrant. And is it positive or negative? Well, okay, the sine is in the third quadrant. So opposite over hypotenuse, the sine is negative. Okay, the reference angle is blank, and the exact value of sine of 240 is, so what's the reference angle? The reference angle is this angle. And so that would be what? Well, we go from 180 to 240, so what's 240 minus 180? That's 60 degrees. Okay, so the reference angle is 60 degrees, and there you can see that, so we're going to be, for all these problems, we're going to be, because they're asking what the exact value of the sine of 240 is, well, we don't know the side lengths, right? So we can only calculate, they're calling it exact value. I'll explain exactly what they mean by that in the next section, but we can only calculate the value of the sine of an angle that's either the angle itself or the reference angle is 30, 60, or 45 right now, unless we have the side lengths. But we don't have the side length. So, well, how do we even do this for a reference angle? Well, we do it because we know the side lengths of like a base triangle, of a 30, 60, 45 degree angle base right triangle. So let's go ahead and we'll draw these triangles down here, and just, I'll leave them for this entire video. So here is I'm trying to make that leg on the left a little bit longer than the bottom leg there. So here would be a 30, 60, 90 triangle, and we know it has, these are the ratios. Okay, now a 45, 45, 90, try to make those two legs the same length. We know has base ratio, the lengths of the sides have the kind of base ratios 1 root 2. Okay, so sine of 240. Well, what do we do? How do we do this? Well, we talked about in chapter 1. We learned that we didn't even need to know what the reference angle was. We just come to this angle here, the angle of the right triangle that has the vertex of the origin, and we just do SOHCAHTOA on this triangle, this right triangle, but you make sure you honor the potential negative signs of the side lengths. Okay, so what we can do here, this is a 30, 60, 90 triangle. We can see, we can go ahead and just put make this 2, that's the hypotenuse, and then, let's see, this is the side that's connected to the 60 degree angle and the perpendicular. So this would be 1, and this would be root 3, but these are minus though. That's the key. And so the exact value of sine of 240 then is, you do opposite over hypotenuse, that's minus root 3 over 2. Okay, the value of cosine of 390 is what? Because 390 is in quadrant. So, okay, same problem, but with 390. So you have 360 plus 30, so that's in quadrant 1. And it's, like something like that. Okay, it's everything in quadrant 1 is going to be positive. This is coterminal with an angle in quadrant 1. So now let's make this right triangle, and this is 30 degrees. So we can go ahead and put the side lengths. I mean, we actually don't even need to. We can say the reference angle is 30. We can see, and then the exact value of cosine of 390. We could. This is an acute angle, so you could actually just come to do SOHCAHTOA on the triangle itself, right? So we're doing, what is this? Reference angle is 30 of cosine 390. Okay, adjacent over hypotenuse, that's root 3 over 2. Positive root 3 over 2. Okay, the value of tangent of negative 150 is, so same type of problem, but with tangent of negative 150. So this is negative 180. Therefore, we come 30 degrees this way. So we can see the reference angle is going to be 30 degrees. Okay, and so the tangent opposite over hypotenuse, or no, opposite over adjacent, that's going to be positive. Because minus 150 degrees is in the third quadrant. The reference angle is 30 degrees, and the exact value is, so, okay, we need to put the leg length, so 2, and then the angle between, that connects the hypotenuse to the right angle, well, but with 30 degrees in between the hypotenuse and the leg, that's root 3, and this is 1. Now, just a reminder, you might be saying, well, wait, how can we don't know what these side lengths are. Like, how can we just use, we don't know if this triangle and this are the same triangle. It doesn't matter. Remember, like, we pick whatever radius we want. You could think of it that way. For the general method, we pick whatever radius we want. So let's just go ahead and pick 2. Why pick 2? Because we could just then, once we pick 2, we could just put these side lengths. Okay, so tangent of negative 150, opposite, well, no, these are negative. I messed that. That was a big mess up there. Those are for sure negative for this method. So opposite over adjacent is, that's 1 over root 3, but then we want to rationalize that. So times root 3 over root 3, you get root 3 over 3. Positive root 3 over 3. Okay, secant of 135 degrees. So here's 180. Well, let's do this. 90. So it's 40. It's 45 degrees in quadrant 2. So the reference angle is 45. Here's the reference angle. And secant is going to be what? Secant is the reciprocal of cosine. So hypotenuse over adjacent, this is negative. So this is going to be negative. Because this is in quadrant 2. The reference angle is 45 degrees in the exact value of secant 135. So we've got negative 1, positive 1, and then root 2. So minus, or it's root 2 over minus 1. So minus root 2. Okay, so let's fill in this table here. Let me move this off to the side so we can see the triangles. All right, so, it's all of these. It's either a special angle or the reference angle is there's 30, 45, or 60. So with 30, 45, and 60, those are going to be the easiest because those are acute angles. And the idea is you could just actually we can come to the triangle, and no matter what the orientation of the angle, just do SOHCAHTOA. So these are all going to be positive. So 1/2 root 3 over 2. Well, yeah, okay. So tangent of 30, opposite over adjacent, that's 1 over root 3. So root 3 over 3. Cotangent is 3 over root 3, which would be, so 3 over root 3 times root 3 over root 3, that's 3 root 3 over 3, that's just root 3. There we go. 45 is going to be, a lot of these are going to be the same, so sine of 45 is opposite of our hypotenuse, 1 over root 2, that's root 2 over 2. And then, so the reciprocal is going to be root 2. Reciprocal of sine is cosecant, so this would be root 2, because 2 over root 2 ends up rationalizing to root 2. Cosine is the exact same thing. And secant is going to be the exact same thing. There we go. Easy. 60 degrees, so opposite over hypotenuse, root 3 over 2. These are all positive. Then you've got cotangent is 1 over root 3, so that's root 3 over 3. We could have come to the triangle or just done the reciprocal here. Yep, secant's reciprocal of 1/2, and then cosecant 2 over root 3 times root 3 over root 3, that's 2 root 3 over 3. Okay, now what happens with the reference, with these, which all these are going to have reference angles of 30, 45, or 60, what does that mean? That means that all of these trig functions are going to have the exact same magnitudes as these, but they might be negative or potentially be negative or positive depending on the quadrant. That's it. You'll never see any of these have some magnitude that isn't in here. For example, you'll never see like any of these aren't going to have a value like root 3 over 6. Because do you see a root 3 or like even negative root 3 over 6 or something like that? Because do you see anything with magnitude root 3 over 6 in here? No. And why is that? Well, because remember, with the general method, all we're doing is we're constructing a right triangle in whatever the quadrant, wherever the corresponding quadrant is based on the angle, and then we're going to that reference angle and doing SOHCAHTOA. Well, in this case, the reference angle is going to be 30, 60, or 45, so it's going to be one of these triangles. And it's going to have the exact same side lengths, except some of those side lengths might be negative. You see? So, well, let me bring this back. So, okay, well, 120. 120. So what's the what quadrant is that, and what's the reference angle? So that's going to be the second quadrant, and so you think 180, and so 180 minus 120 is 60, so it's going to be a 60-degree reference angle, okay? And so if you think about it, okay, that's great, but what's the difference? Well, the right triangle is going to be just like this. I mean, we can actually take this and slide this up here. The only difference is that this is going to be negative, the horizontal. Okay, so we've got root 3 over 2, that's right. Then this would be minus 1/2, and so then secant is going to be minus 2 reciprocal, and then cotangent is going to be not opposite over adjacent, but adjacent over opposite. That's going to be minus 1 over root 3, so minus root 3 over 3. That's it. Okay, 135 it's 45 degrees in the second quadrant. And so it's this triangle, but with a negative here. You see? So, okay, you've got sine root 2 over 2, and then cosecant root 2, that's right. And then, yeah, you see minus root 2 over 2, because that's minus 1 over root 2 rationalized. And then 2 over root 2, that's going to be just root 2, right? But it's the reciprocal, so, well, minus root 2, okay. So we just need to get tangent and cotangent. So tangent is minus 1, cotangent is minus 1, right? opposite over adjacent, adjacent over opposite. But this is negative. That's the key. All right, 150, so that's going to be second quadrant, 30-degree reference angle. And so we can't really, and so it's kind of hard to visualize if you were to, you could take this triangle and like spin it like this into the page or out of the page and then back into the page. And then you could put the 30-degree angle there. But all that's going to happen is the horizontal is going to be negative. That's what happens. You see, you've got, there's 30 degrees. You see, you've got 2, and then the perpendicular between the leg and the hypotenuse, the 30-degree angle, that's the root 3 here, and that's negative. And this is positive, you see? So, okay, with that, we've got sine is opposite over hypotenuse, just 1 over 2. Cotangent is not opposite over adjacent, but adjacent over opposite. That's going to be minus root 3. And then secant is the reciprocal of cosine. So we can just come here, 2 over root 3. That's going to be 2 root 3 over 3. So minus 2 root 3 over 3. So secant of 150, not adjacent over hypotenuse, but hypotenuse over adjacent. This is negative, yeah. Okay, 210, that's 180 plus 30 is 210. So we're in the third quadrant, and the reference angle is 30 degrees. And so in the third quadrant, both of these legs are negative. And we're dealing with 30 degrees. So, okay, cosine is adjacent over hypotenuse, so minus root 3 over 2. Okay, and then secant's the reciprocal of cosine, so 2 over, or minus 2 over root 3, that's minus 2 root 3 over 3. All right, 240 is third quadrant, 60-degree reference angle, so these are both negative. So, okay, tangent opposite over adjacent, that's what's positive root 3. Cotangent 1 over root 3, that's going to be root 3 over 3. Okay, find exact values of the 6 trigonometric functions of each angle, rationalize denominators when applicable. So, what do? We see what quadrant is this in? What's the reference angle? So, and you know, again, I just want to remind you, you know, why normally we wouldn't need the reference angle, but if you can already determine the side lengths of the triangle, the right triangle, you don't need to know what the angle is. But if in this case, we need to know what the reference angle is, so we know which, you know, so we can determine the side lengths. And in problems before this, in like chapter 1, we were already knew information about the side lengths, so we didn't have to determine what the reference angle was. All right, so 300, so you have 360s of full rotation. You go 60 here, so we've got something like this. In the fourth quadrant, and the reference angle is 60 degrees. It's the angle, the line of this line here, the terminal side line, makes with the horizontal. Okay, so that means this is 30 degrees, and we could put side lengths 2, 1, root 3, well, no, minus root 3. The 1 is positive, but this is negative. So now we do SOHCAHTOA with this angle. Like, it's not, we don't care that it's 60. Like, you know what I mean? Like, we could effectively, now that we have the side lengths, this angle is irrelevant. We're not thinking what's cosine of 60. No, this is what's cosine of 300, right? That's what I don't like about like the reference angle, because you only potentially need to know what it is. the reference angle to get the side lengths. But once you have the side lengths, you can effectively erase this, because the tangent of 60 is not minus root 3 over 1. It's root 3 over 1, right? So, but, okay, we come to this angle and we do SOHCAHTOA. So, all right, sine of 300 is equal to opposite over hypotenuse. Okay, so then secant of 300, we could do SOHCAHTOA again, or we can just take the reciprocal. So minus 2 over root 3 times root 3 over root 3 would be minus 2 root 3 over 3. All right, cosine of 300 is adjacent over hypotenuse. The 1 is positive. And then so, or wait, no. This is cosecant. And then this is secant of 300 would be 2. All right. Tangent 300, opposite over adjacent, so minus root 3. Cotangent 300, adjacent over opposite, minus 1 over root 3 would be minus root 3 over 3. Okay, 480. What is that coterminal with? So you do 360, and then to get to 480, you go 120. All right, so 120 is in the second quadrant, and that's 60 degrees less than 180. So we're like around here. Okay. And that the angle that this terminal line here, I mean, this is the angle. But the angle that this terminal line makes with the horizontal is 60 degrees. That's the reference angle. And we just need to know that in this case, because now we can know what the side lengths are to put. So we're going to put a 2 here, and then between the hypotenuse and the 60-degree angle, that leg is 1, but this is minus 1, and then this was root 3. Okay, so sine of 480 is equal to opposite over hypotenuse. Okay, so then cosecant of 480 is 2 over root 3 times root 3 over root 3. That's 2 root 3 over 3. Okay, cosine of 480 is adjacent over hypotenuse. So secant of 480 is minus 2. Tangent of 480 is opposite over adjacent. Cotangent of 480 is minus 1 over root 3, so that's minus root 3 over 3. Okay, 1305. What is this? So 1305 divided by 360 is 3 rotations, and then 0.625 of a rotation. So 0.625 times 360 is 225. So this is coterminal with 225. 225 is the third quadrant, and that's, so for you to go from 180 to 225, you go 45 degrees. Okay, so the reference angle is 45 degrees, and the actual main angle, you do 3 rotations, so 1, 2, 3. And then the reference angle is 45 degrees. This is 45 degrees. So we've got minus 1, root 2. All right. sine of 1305 is opposite of hypotenuse, minus 1 over root 2. That's minus root 2 over 2. Cosecant 1305 degrees is, so hypotenuse over opposite, that's minus root 2. Cosine of 1305 degrees is going to be the same. It's going to be exact same, right? Adjacent of hypotenuse, so minus root 2 over 2. And then secant 1305 is going to be just minus root 2. Okay, tangent 1305 degrees is going to be 1. Cotangent 1305 degrees is going to be 1. Okay, minus 510, we've got, so 360 in the negative direction. So what is 510 minus 360? So 150. So we go 360 and then minus 150. So minus 90 and then minus 60. So it's kind of confusing, but the reference angle you can see is going to be 30 degrees. Reference angles are always positive and acute. Always. Even though this is a negative angle. So this is that's minus 510 with the reference angle 30 degrees. So we've got 2, and then this is 60 degrees. The angle between the 60 and the hypotenuse. So this is 1, this is minus 1, and then minus root 3. So sine of minus 510, opposite of hypotenuse, minus 1/2. Cosecant minus 510, therefore is minus 2. Cosine minus 510 is adjacent over hypotenuse, so minus root 3 over 2. Secant minus 510 is minus 2 over root 3, so that's going to be minus 2 root 3 over 3. Okay, tangent minus 510 is, so opposite over adjacent, that's 1 over root 3, that's root 3 over 3. Cotangent minus 510 is adjacent over opposite, so just positive root 3. Okay, minus 1860. We've got, so what is 1860 divided by 360? So it's 5 revolutions in the negative direction, and then this much of a negative revolution. So 60 degrees. So you go 5 revolutions, and then you go negative 60 degrees. So we can see the reference angle is going to be 60 degrees. And I'm not going to draw the 5 revolutions. So we've got 2, and then this is minus root 3 and positive 1. So sine of minus 1860 is opposite over hypotenuse, minus root 3 over 2. Cosecant minus 1860 is 2, or minus 2 over root 3, so minus 2 root 3 over 3. Cosine minus 1860 is adjacent over hypotenuse, And then so secant of minus 1860 is 2. Tangent of minus 1860 is opposite over adjacent, so minus root 3. So cotangent minus 1860 is minus 1 over root 3. That's minus root 3 over 3.